Well, first of all, thank you very much for inviting me. I have been thinking and working on consumer privacy for about 10 years. And I'm so excited to be talking to this audience where I know that everybody here cares about privacy. We have a very hard and very important problem, and we need the help of everybody here. As we heard from the keynote this morning, before we talk about the next problem, we should look at our history and learn from it. So let's talk about our current situation. What we have today is not a billion-person problem. It's a 2 billion-person privacy problem. Do you know what I'm talking about? Anybody? Nope. It's Facebook. Okay? Because in order for us to share, we are giving up our data to this company, and they own our data. I just want to know, just curious, how many people here are on Facebook? Okay, let's flip that. How many people are not on Facebook? Wow, I think I'm at the right conference. Okay. So Facebook actually has an incredible service. They said, we're just going to help you share with your friends and family. It is really convenient, really easy, and it is all free, right? Or is it? This is their terms of service. They start by saying you own the content you create. And I said, great. What are we complaining about? What are we worried about? And then it went on. It says, you grant us a non-exclusive, transferable, sub-licensable, royalty-free, worldwide license to use any IP content that you post. Okay? That means that you own the content, but in 3 simple words, so do we. Okay? And so the question is, what does that mean? I suppose we all know about Cambridge Analytica. We know that they can do psychological experiments on us and so forth. They can sell the data and so forth. And this, like, is there a solution? Do people know about it? So I did my experiment. I asked my undergraduates at Stanford, and I say, do you know that Facebook owns the data? First of all, most of them don't. And when I explain it to them, and the first response is, oh no, I'm going to get out of Facebook. And it would last about 5 minutes. Okay? Why? Because there is no alternative that they can turn to. And I really think that this is not the consumer's fault. I believe that it is the technologist's fault that we do not create an alternative that makes it easy, makes it possible for them to share without giving up the ownership of their data. So that's water under the bridge. We will not solve this problem. So what we need to do is to learn from the history and look at the future. What do we have in store for us? Okay? And the point here is, like, this is the next billion-person privacy problem. And the biggest boss or the biggest brother is yet to arrive. And I think that the answer is that it's going to be the virtual assistants. Why? The virtual assistants have a very, very compelling value proposition. We all have data everywhere, Facebook being just one of them. We have data on IoTs and all the different services. And the virtual assistant said, look, just give me your credentials. Give me all your passwords. I can look at all this data. I can provide for you the best interface for you because it will be personalized based on everything that you have. And now you have a natural language interface to all the data that you have. Isn't that wonderful? Okay. What it means is that, say, if you get your, you submit it to USENIX and you got an acceptance, and your virtual assistant can go ahead and book you a plane ticket to Baltimore. They know your calendar. They know what you like. They have your credit card. They will book the ticket and they say, look what I got for you. Oh, of course, you can cancel within 24 hours. All right? And that's where we are heading, and I think it is just a matter of time. So what we see here is that virtual assistant is going to be the new intermediary between us and everything digital, websites, search engines, mobile apps, IoTs, what have you. All right? You can have the virtual assistant sitting in between. That means that they will have a choice of the vendors. And if they put out services, they will be, they will provide the best. They will have the best credit cards because they know the credit risk of all the people that they are serving. And what they are doing today, they are creating a proprietary platform of skills. Google has 1 million functions. Alexa has 40,000 skills. These are all proprietary systems. You go through them, you put the skills onto their system. It belongs to them, okay? And it is up to them to use whichever that they wish. You know, it is kind of hard to believe, but that for example, Google will direct a lot of search queries to Bing, for example. So there's a whole lot of control by being this intermediary. So this is what we think, and if you worry about Facebook, imagine Amazon, Facebook, Google combined and even more. And that's where we are heading. So what can academia do? Okay, to answer this question, let's first of all understand the problem. And Professor Tembu, law school from Columbia, had a very interesting phrase that he coined that I loved. And he just says, the tyranny of convenience. And he said, convenience has the ability to make other options unthinkable. Right? What does it mean? What it means is that if you want to solve this problem, the number one thing we need to do is to make convenience a priority. But it is not a standard academic priority. Convenience is almost never used as metrics for paper acceptances. Okay? And I still remember there is this talk that Butler Lamson gave at the SOSP conference, the premier OS conference, 1999. And of course, he talked about transactions, the robustness, recoverability, serializability, you know, all those buzzwords, all those words that we all learned. And at the very end of the talk, he turned to the audience and he said, I'm very disappointed. I'm very disappointed that we didn't invent the web. Do you see the irony there? I still remember Margot Seltzer got up and he says, and she said, Butler, that's because we listened to you. Why? The web is full of inconsistencies, dangling pointers everywhere. How can any OS person write up the web? But the whole point here is that that's convenience. And we have to embrace convenience. Otherwise, we are not relevant. Okay? So that's the first part, convenience. The second part. So Tim Wu also made another statement. He said, convenience and monopoly seem to be natural bedfellows. And that I disagree with as a technologist, because I actually know that there are alternatives way of building systems. And that is that we really need to build these open, distributed architecture. If you have it open, distributed, interoperable, then you can have competition. And with competition, you may be able to find somebody who helps protect privacy, because now there is a choice. If there is no choice, all you have is a monopoly, why on earth is this monopoly ever going to protect your privacy from themselves? It does not make sense. So do we know of a distributed architecture? A distributed community architecture for consumers? Yes. It is called email. It is still kind of very much in use, but it's on its way out. Okay? It is a distributed it's useful for distributed consumer communication, and that was invented in 1972. Okay, this is pre-ARPANET. So what have people done since then? What have the academians, the technologists done since then? Okay, and with email, what it means is that there are a lot of potential service providers, the Google, the Yahoo, or the Verizon, and the Microsoft. They have competing services that are interoperable. And that means at least you have a choice. And then there are people who stand up email servers that you can pay. And if you are Hillary Clinton, you can even run it on your own home server. Okay? But if you don't have open competition and interoperability and choice, you don't have privacy. So that comes first. So that's what I learned as I was thinking through these problems. Privacy, to get privacy, let's make sure we have open competition and interoperability. So we've been thinking hard about this, and what we decided that the way to solve this problem is to turn the virtual assistants from the foe to a friend. Okay, there are a lot of AI projects, and most of them, it is all about getting more and more personal data. But what we see here is that AI can actually help you protect your privacy if you do it the right way. All right? So this is what we have done, and there are 3 steps that we have taken. The first is that we focus on convenience. We want to develop the technology to make virtual assistants even more convenient than the commercial products. And we take this technology and make it open, so everybody can compete on the virtual assistant. So that's the first problem, the first goal. The second thing that we do is to say, look, the distributed systems is the way to go. But distributed systems are notorious in the ease of use. Okay? It is really hard to use. So now we say, look, virtual assistants are making things convenient. We turn this around and make the virtual assistants provide us with the convenience so that we can share with each other very easily. Okay? So that's the second part of this project. And the third thing is that we build a prototype. The system that we have built is called Almond. It's an open distributed virtual assistant. And what we want to do next is to really want to create an open virtual assistant movement. We want to work with everybody. It's a problem very big. Virtual assistants are really, really expensive to build. We need help from academia. We also think that it would be a great thing to get the industry involved. If you are not one of the front runners in the industry, maybe the open source is the only alternative to stay competitive. And I just want to kind of ground this in something like real. If you imagine Apple, okay, they said they care about privacy. They have used open source in building their operating system. If they were to embrace something like this, that could change the field because they have very big distributions. Okay, so that's what I'm going after. Now I want to convince you this is worth doing and this is possible. So let's start. How do you make virtual assistants even more convenient today? And the idea that we have been working on is the concept of programming the virtual assistant. If we can program the virtual assistant, then we have the versatility to match the individual needs of the consumers. But when we say programming, I'm talking about programming in natural language. I'm not going to ask people to learn how to write JavaScript. That is not convenient. So let's take a look at how our virtual assistant compares to the commercial ones. In the commercial virtual assistants, every skill that the virtual assistant does needs to be hard-coded. And if you look at their repository of skills, these are intents. And what they do is basically a dispatch as a switchboard service. They have the intent, you say something, and then they send it to the right service. So for example, if I say, ask Bing to search for X, it will take that and send your sentence to Bing and let Bing handles it. And so the information goes out, but it doesn't come back. What we need to do in programming is that we need to be able to combine functions. That's what we mean by programming. We have to take information from one function and give it to another function. And then you can put filters and so forth. That's the concept of programming. So if you look at our repository, we don't just put in the intents. We absolutely have the full API signatures. And this is how we can get the results. We take the result from one and we pass it to another. And this is how we get the interoperability between the Internet of Things. So this repository is very, very important, and we have to make it open to everybody. Okay? So that's the basic idea. So technically, that's what it means. Let's take a look at what it means for a real user, potentially, with this technology. So here's an example. Here we have Bob. Bob has asthma, unfortunately. It is something that it's like 8% of the population has asthma. And it is not a particularly profitable thing to help asthma patients per se. But if we have natural language programming, we can let Bob take care of himself because he can say what he wants in natural language and have the code be automatically generated. So here are just some examples. We have Internet of Things. So Bob can say, look, I really want to know where I get the allergies. Okay? So he can say, look, here is my inhaler. It's an IoT. I can say that when I use this inhaler, record the GPS location and put it in my file. All right? That's information. And, for example, he can get an attack. He may be taken to the hospital. He wants his virtual assistant to constantly monitor his location. If we have privacy, Bob doesn't mind. Says, constantly monitor my location, but if I get taken to the hospital, please tell my dad. I don't want my dad to know where I am all the time, but under this circumstance, it makes sense. Now, this information is just not for him because he also needs to communicate it. So maybe his doctor, Dr. Smith, would like to give him continuous care, which is possible now with these IoTs. He can say, look, if Bob's peak flow meter drops below some threshold, let me know, because I may want to take some preventive measures. And in this particular case, this is just a sentence that Dr. Smith said, and the code is automatically generated. And we all know that healthcare information is very hard to share. With this model, what it says is that the hospital releases the information to Bob, and Bob communicated with anybody he wishes. Okay, so that's a different model. We don't have to have the patient, the hospitals talking to each other. And finally, there's this concept of environment, of course, where the doctor can say, look, you shouldn't be running under these circumstances. And now this is something that the virtual assistant can do. Everybody's use case is different. And the real good way of supporting this is to let the people describe what they want in natural language. So that's natural language programming. Okay? Let's get into this a little bit further. So this is a sentence that I used earlier. Just take a look. There are a lot of programming concepts embedded in that sentence. When, that's event-driven programming. I am using the inhaler, GPS box. These are all different functions. I have to call these different functions and connect them using parameters. And then I may also put filters because I really don't want to enter all the locations if they are home. It is really, I don't want to have too much data in my file. So these are all programming concepts. So what we need to do is to take these natural languages and turn them into code. So what kind of code would it look like? Is it JavaScript? Is it, what should it be? You really need a very high-level programming language if you want to do this translation. So we designed our own language. We called this ThingTalk. And that's what that program looks like in code. The 3 lines on the left-hand side looks like 3 lines on the right-hand side. It matches one by one. The first sentence is when something happens. The second one is get some information. And the third one is do something. A when, get, do. Very, very simple construct, but as you can see here, there is a very high-level correspondence between the left and the right, and that's key to making semantic parsing, the translation, possible. So the construct is very simple. The strength of this programming language is the libraries, okay? It's the kind of functions there are. And we have our library, we call this Thingpedia, okay? So it's like Wikipedia, but it is an encyclopedia of how things work. And this is the one we want to make open to everybody, all the virtual assistants. And that's why we have a very powerful language, even though the construct is very, very simple. The problem of translating formal and natural informal language to the formal language is called semantic parsing. And our software is called LUI-NET. LUI is linguistic user interface, as opposed to GUI, which is graphical user interface. This is going to be very important going in the future. There will be linguistic interface to everything we are doing. It is not necessarily exclusive, by the way, but language is so much more powerful, and we have the technology. So LUI-NET here is this translation from natural language to a formal language. So let's go down a little bit more in details. So here is your Thingpedia. At this point, we have crowdsourced about 60 devices, 200 functions, and it contains a lot of the typical things that students care about. Okay, so for example, you can see here there is this PhD comics. I mean, it is something that they just cannot do without, right? So these are all the public APIs. You enter this information into this Thingpedia. Now you can program with it. Okay. And as we mentioned before, our representation, which is really the key, is how do you represent information? Is that we are not just intent, we have the full signature. We said that there is the when, get, and do. So take an example, if I look at Twitter, the when is like I can monitor when Stanford tweets. And that's the English, and that is the code for it. The get is that I can get information, and then do is that I'm actually making a side effect, okay? So these are the kinds of APIs that are available to in Twitter, and we know the natural language correspondence to those sentences, okay? That's what goes into the repository. The important thing about this repository is that it is open. It's open to everybody. Alexa, Google, anybody can use this repository. As a matter of fact, we have done, so for example, some of our students created a really good Spotify skill, and this Spotify skill is available on Amazon, Google, and Almond, okay? So we want to say, if we put this all together, anybody can build a virtual assistant that has all these primitives. We don't want it to be locked up into these proprietary repositories. And so with the 200 functions, there are quite a few whens and gets and do's. And so you don't have to read them, but it gives you the idea that if I want to compose a program out of these different parts, you really don't want to deal with a GUI. You really need the power of the language. So now let's look at the construct. We say there is the when, the get, and the do, and then there are filters in between. So if I look at all the sentences that we used earlier, can all be parsed into this formal language, even though it's a very simple language. Okay? Of course, it does not have to be related to health cases. And here's just another example. Okay? It's like when the Bitcoin price reaches $10,000, search for a Bitcoin picture and tweet it with caption, "I'm rich." Okay? So you need to write a rule because who knows what happens to the Bitcoin prices right after it reaches the 10,000, But what we are showing here is that every person is interested in different sentences. We let people put them together. So where is the hot problem? The hot problem here is that you can't just put these snippets together in the repository and expect all the users to be using those same snippets. You have to deal with natural language. So here is an example of a rule. It is very useful. It reminds you if your car is at home and you didn't plug it in so that, you may not have enough energy to drive it the next day. But there are so many different ways for saying it, and that's why we have to turn to AI to get this to work. There are a lot of technical challenges. I don't have the time to go through them. For example, how do you design the language? How do you design the representation? Because it interacts with the accuracy of the LUI-net, the neural network, it took us a couple of years to iterate between those three things at the same time, combining language and data representation and AI together to get to a point where we have a model that can train. How do you handle the inaccuracy? Maybe you complement it with a GUI, and how do you teach these users the scope of the formal languages and so forth? So the good news here is that with the experiments that we have done, we know that this is possible. The results are preliminary. We cheated a little bit. Right now, when we put in the sentence, we put quotes around the parameters. So for example, we say, play the song Born Free on Spotify. And if you put the quotes in there, we discovered that we have been doing really good with all these compound sentences and reaching over 95% in identifying which functions they were talking about. And the full program accuracy is almost 90%, okay? And this is with limited training, and we still have a way to go, but at this point, I am 100% sure that this is going to happen. If we can understand images in the natural scenes, we will be able to have a neural network that understands every public API out there, and you will be able to invoke them using natural language. It is just a matter of who owns it, and I want it to be owned by everybody. Okay, so that is the the idea behind natural language programming. So let's apply this. We said it is very important to have convenience. Let's use this and apply it to sharing and also guarantee privacy. The goal here is that I don't want to do all this technology and have it all be implemented in the proprietary systems. We need to build the decentralized systems now so that there is a platform that uses this technology before it becomes a monopoly that you cannot dislodge. Okay? So here is the architecture of our system. It's a first distributed virtual assistant architecture. So as an individual, I can use the LuiNet for translate. Everything is open source. So the virtual assistant is open source. I can run it on my own device. Of course, it could be hosted by somebody else, by other people as well. Okay, like I said, I don't expect everybody in the world to host their own. But if it is interoperable, then you have a choice of vendors. You have a choice to have privacy. So the Almond virtual assistant is currently available. It's a research prototype. It's an Android app. It's a web prototype. And now you can run it on your own machine. And that means that you don't have to give your credentials to your banking account to anybody else if you want. Now, that's me. I have my home system. You can have your system. So wouldn't it be nice for us to take advantage of this to share information between the different parties? Okay? And that's why we created this protocol, the protocol to let the almonds talk to each other. And we call this the distributed ThingTalk protocol. Remember, we were talking about email, SMTP. That's a long time ago. That's a protocol of the last century. Okay, what we need is a protocol for this current century. It has to be a lot smarter, and this is what we are playing with. All right, so let's talk about sharing. So what we see here is that the virtual assistant already has your credentials. It can do so many things already. Why don't we make the virtual assistant your agent? Okay, meaning that if you want anything from me, you talk to my agent, my virtual assistant, and my virtual assistant can do this for you. It has a lot of very, very good properties. First off, remember, convenience is the most important thing. It's convenient because it understands the natural language interface. Okay. Second, it is very general. My virtual assistant can share with you anything it can do. Remember my ThingTalk program with all the functions? Anything that can be done with ThingTalk, you can get access to. Okay, so it's extremely fine-grained. You don't need to have my password in order to read my Facebook pictures. My virtual assistant can give you exactly what you ask for. Third, I can do control. Okay, we take the natural language programming concept and we created an access control programming language, which is a superset of the ThingTalk language that I just told you. It's extremely precise in what I let you do. All right, so now I can say it in natural language. So now I have control. Now the next question is privacy. So when you ask for something, that ThingTalk program is actually executed by my virtual assistant on my potentially own devices. I never have to share anything else other than the results that you ask for. So now we are doing basically remote execution. Okay? Remote execution. We now worry about security. We know that if I send a program to you, it is very, very dangerous. So how do we solve this? Is that when I send you the program, it's in ThingTalk, you have to ask the owner for the permission to execute exactly that program. Because the language is at such a high level, I can translate it back into natural language and ask for the permission. You know exactly what is being allowed. It is not like I can say, let me get access to your gyroscope. And after you get the access to gyroscope, you can discover all kinds of things. No, I am just giving you exactly the result that I approve. That's really important. So that's the security. And then finally, correctness. All right, we're talking about this informal language. How do I know what I'm sharing? And the good news is that we translate it into a formal language. And the formal language, we take it down one lower level, and we represent all the access control as SMT formulas. These are the satisfiability modular theories formulas, and they are provably correct algorithms that we can use to check for conformance. So those are the properties of this idea that you use the virtual assistant for sharing all our digital properties. So let's take a look at this as an example. Imagine here is the father, he has an assistant. The daughter has an assistant. And the father, his daughter is a grown daughter, and she travels a lot. And the father said, let me help you with your security. I want to see your security camera whenever you're out of town because I check if something goes wrong in your house. So in this case, the father would say, okay, ask Alice to notify me when her security camera detects motion. He says it in English, and that's Almond converts it into a program. So that is what ThinkTalk looks like with being able to execute remotely. And then the dad's assistant sends it to Alice's assistant. The Alice Almond next has to make sure that it is allowed. So it looks up its policy database and see if it is allowed. Now, Alice is not an IT staff. She's not going to sit there and write down all the access control ahead of time, because that would just never fly, okay? So what we have implemented is access control on demand. So Alice looks at this program and says, nope, you don't have the ability to do that yet. Let me go ask Alice. And the way the Almond asks Alice is that she takes the program that you see here and translates it into English. The English is a little bit clunky, okay, because this is what exactly it says in terms of the various snippets. It is accurate. That's one thing that we want, is that we make sure it is accurate. Notice that it is, Alice didn't take the father sentence and share it with Alice. It was actually translated by the virtual assistant that Alice has, okay, to match the semantics of the program that is to be executed. So at this point, Alice looks at the English and says, should I approve this? What do you think? No. Alice says, no, I don't want you to be snooping on me. I may have all my boyfriends there and whatnot. And so Alice says, okay, only if I'm not home, right? If I'm not home, then it should be empty. And if something happens, I am traveling internationally. I don't get to monitor it. So send it to my dad, okay? So now she says that's in English. This is translated into a formal representation. And at this point, the assistant takes the original program, add in the access control, and create a new program, which is described there, which basically says, send dad the information if there is motion on security camera, only if Alice is not home. Alice is not home is measured by the GPS that Alice has, and with the privacy, it is all fine. And the information is then only sent back to dad's assistant. And only that information is sent back, and the information is then reported to dad. So that's the sharing policy. And it is general because it executes any ThinkTalk program that can be written using the Thingpedia repository. So what does the ThinkTalk language look like? We take the ThinkTalk and we just added two more things, the requester and extra predicates like my GPS locations and so forth. So it parses a whole bunch of sentences, and it really matches those lines. We have some preliminary machine learning. It is really not accurate enough, but it is just a matter of time and data. And so we augmented it also with a GUI so that you can use that. The GUI is automatically generated from Thingpedia. Okay, nobody has to handcraft the GUI, but it's going to be very precise. So now you take this natural language, we transform this into TACL, into ThinkTalk. We then lower it to SMT formulas. So it is all very formal. This is what it looks like. I don't have the time to explain all this, but the mapping is very, very close. And once you map it, you can solve the whole bunch of conformance problems or finding the programs that is the least restrictive, that satisfies the constraint, all by solving a bunch of satisfiability problems, okay? Satisfiability problems are NP hard. The good news is that we did some experiment where we can check a program against 50 policies with the same functions, and it finishes in a reasonable amount of time. So that's the technical part, and that's the easy part, okay? Let's talk about the users. Do they need it? Do they want it? Do they accept it, okay? So we did a little need-finding survey of 200 people on Amazon Turk. No, these are not computer science, definitely not security engineers, okay? So we came up with a bunch of things that people may want to share, and we asked them if they want to share. So for example, credit card on one hand, and then Netflix account on the other, and people, out of the 200 people, some percentage of them say, I'm comfortable with that. And then we said, what if I can add extra constraints? For example, your daughter could use the credit card only for restaurants within a $20 budget limit. And a lot more people said, sure, that is fine, okay? So for example, an Amazon courier can open the door if the package is over $1,000 and if you have a security camera on, okay? So these are some examples of how these are access control. And as you can see here, they are all different depending on what you are trying to do. So this access control has to have the flexibility, and that's where the language comes in. So we did it for, it's not just 5. I mean, we can come up with many, many examples. This is across 20 examples. As you can see here, the number of people saying comfortable pretty much doubles in terms of use cases. So these are examples that we ask. Do the consumers figure, can they come up with their examples that they care about? So we turn them around and we say, look, can you come up with something that you want to share, but you want to have constraints? And so some of the examples are enforceable. Here is one. It says, the mom says, you need to follow this guy on Twitter and give me your Twitter account. You see, people usually share by giving people's account passwords. And I said, okay, but just only at him. I don't want to see all the other people that you like me to follow. So this is an example that is enforceable using the system we have today. This is something that is not enforceable. A friend says, can I use your library card? And then you say, okay, only if you return the book on time. Now that is not enforceable. My whole point is that when we ask the Amazon Turkers, we did not explain to them anything about ThinkTalk or TACL. We just asked them, do you have things that you want to share and the constraints? So we have a very diverse set of uses without knowing what our system can do. So what is the result? We asked 60 people, and they came up with 220 suggestions. They have all kinds of things that they want to share. There are 85 unique different things that they have come up with. And we plotted the frequency. It's like 34% is personal data, IoT services like Netflix, social media like Twitter, business account 1%, that's like the developer account and so forth. So they come up with all these different things that they want to share. And what are the constraints like? So we look at all the constraints that they came up with, and to our surprise, 70% of the constraints that they come up with, we can actually do today with existing APIs. Okay? They are not necessarily in Thingpedia, because this experiment is just to check the expressiveness of the language. 70% is already available. 15%, it is not available. For example, one common use is like, can I borrow your phone to make a phone call? You would say yes, but only make a phone call. Now, this is something, for example, that the phone manufacturer may want to add to their phone so that they can let somebody make a phone call. But 15% is not available today. And 9% is out of scope. An example is like, you can use my credit card, but not more than $40 in 1 week. Okay? So this is aggregation. It is not something that we have, but it is something that we will put it in the future because it is really useful. And then only 6% are really unenforceable. This is really among non-technical people, like sharing library cards and so forth. So I think that this is very, very promising. And then we finally do the scariest test, is like, will people actually use this system? And we did the study with only 20 people. And what we learned from them when they looked at our system, they said, we get it. This is sharing without sharing passwords, okay? What it means is that the consumers, they have always been sharing, but the sharing is done by letting the other person has the password so they can do what they want. And then it is really like just gentleman's agreement that they will not do more than what they were asking, the limited use case they would like to share the passwords for. And the results, quite a few people like the concepts. Remember, this is a research prototype, but actually more than expected number of people say they like the app, and then, of course, using the app, there's a smaller number. But it is still a very, very good result, I think. So I think that people do care and understand access control, but we really haven't innovated in consumer access control for years and years and years. So in summary here, just a few things to take away. The first thing is the objective. Tyranny of convenience. Don't forget about convenience. It is our duty to make things convenient. Number two, you care about privacy. Let's get to competition first. Monopolies are much worse. Third thing is that there is really a new opportunity for making things convenient for end users, and that is natural language programming. It is absolutely going to happen. The question is it only available by the monopolies? So that's why we need to create these distributed systems right now. And the concept of communication virtual assistants is a way to help people serve throughout. And this is the reason why I think that this is a very hard problem. I mean, Amazon has 1,000 engineers building their virtual assistant, okay? And so what I have outlined is a prototype. There are a lot of very interesting technical problems and definitely needs a lot of help. And so we really want to encourage the community to help out in creating this this software movement. We need a Thingpedia, which is the library of open interfaces. LuiNet, the translation from natural language to code. Almond is a working distributed open source virtual assistant, and DTP is the distributed ThinkTalk protocol so that you can have different virtual assistants interoperate together to help the users share. And if we are able to do this, we can put the consumers back in the driver's seat as opposed to what we have today. Well, thank you for your attention. Thank you.
Hello, hello. All right. Thanks, Monica. Oh, we got quite a lineup of questions. We'll see how far we can go. Name and affiliation.
I'm Mark Seiden from the Internet Archive. I have a quick question about your example. The father asked for certain information. The daughter said, well, you can have that minus 20% or that minus something. The father never heard that what he was getting back was different than what he asked for.
No, we do. We tell him.
Oh, you do tell him?
Yes, it is very important.
Because you jumped directly to he was getting events, and it wasn't a negotiation. He didn't understand the limits of what he was getting.
Yes, I just want to shorten the presentation.
Thanks very much.
It's very important we do that.
I'm David Lee, University of Toronto. Very nice talk. I was particularly interested in the access control that would be universal, and whether you've thought about this in the context of lawful access. So, like when you're at lawful access. So, like when you're at the airport and the agent says, "Can you unlock your phone?" So I can just look to it, make sure, it's a real phone, or the FBI wants to know if you've been in a certain area at a certain time or something like that. But you don't want to give them your password or your whole device. You just want to tell them, I haven't been there or something like that and prove it.
I presume you can work that in, and if it is something acceptable to the law enforcement agency, that would be great.
Hamza Harkus from EPFL, Switzerland. So I want to start just from the convenience part just to have a question about the approach that is being taken. So if we start from Apple, which is now
from what?
From Apple as a company, which is doing Siri, that is trailing behind Amazon and Google Assistant. Apple already has all the knowledge, all the technology for going after Amazon or Google. It's just like Amazon had like a data advantage and the user advantage.
Yeah.
Now, isn't what is being done here is taking a step even going behind? Let's go back from where Apple is, do something open source, do something where we give away convenience in a sense because we require users to deploy their own instances, buy their own devices, and then also doing something which is usability-wise potentially problematic, like asking users to do their own rules instead of having the system work by default. Isn't this all like taking a step back from where we are and going even behind what companies have reached at this point?
Very good question. I know that there are a lot of, like Google Now, they provide you with a lot of information. You don't even have to say it, right? But guess what? I cannot imagine my secretary is all just going to guess what I want. Okay? That would be such a miserable experience for me. I need to be able to tell my assistant what I need to get done. It is not just based on what I have to do in the future, what I have done in the past. So the expressiveness is very important. I want to be able to say what it is that I need to do next. So that's the first part. The second part here is that if you look at Apple, I see it as being cooperative, meaning that they have a lot of primitives. And as far as I know, there is no virtual assistant who knows how to plug things in together. Have you heard of this website called If This Then That? They said they have millions of users. So there is a need for people to plug things in. But if you look at If This Then That, number one is like if you want to execute a rule, like moving your money between banking accounts, you have to give them your credentials. Second, they don't have a natural language interface, and they don't have a formal language to ground it. And what I'm seeing here is an opportunity for the technologists to do something without the kind of data that companies have. And that's what we're trying to do, to look forward a little bit. It's like you really want to be able to express them. And let's get started on this, and hopefully we can all work together. Thank you.
So I'm afraid we have just one more question time. So one more question. Maybe Monica would be willing to stay a couple more minutes later, but
I'm happy to stay around.
But one more question. Yes.
Right, thanks for the talk. Tavish Vedder from Georgetown. So I have a question about the user study that you did. So you did not tell them about, like, especially the first part where you gave them the first sentence and then you added a second predicate, like 10% are limiting the amount of expenditure. So did you tell anything like it was related to voice assistants in particular? Or
related to what?
To voice assistants, like they will be doing this over like a virtual assistant, or was it just told to them that, okay, this is thing, would you like this to be happen or not?
No, we didn't tell them anything about voice assistants.
So that brings my second question. That only tells that they would like to have this control, but this does not tell whether they would want to do it over a voice assistant.
So this is why we have to have the end-to-end experiment at the end.
Okay.
Right?
All right.
So we are just doing need finding. Then the second part is that is the technology, is it expressive? And then that's why we had the third test. So we showed them the app and they played with it and they say, would you use it?
Thanks.
All right. Well, thank you, Monica.
All right. Thank you.
Again.